Assalamualaikum and hello everyone. Today we are going to learn Chapter 3, Application of Differentiation, mainly focus on related rates. There are many of real-world situations that calculus can apply to. In previous class, we have learned about the chain rule and also implicit differentiation. We are now ready to look at some of the applications, the concept of related rates. At the end of this lesson, you should be able to apply the differentiation technique to the related rates problem. The rate of change is usually with respect to time. If y is a function of t and x is a function of t, then we will get dy over dx is equal to the derivative of y with respect to t over the derivative of x with respect to t. If we rearrange it, it will become dy over dt multiplied by dt over dx. In this case, the rate of change of y with respect to x can be found by finding out the rate of change of y with respect to t and that of x with respect to t. Let's look at another example. If A is the area such that A is a function of x and x is a function of t, then the rate of change of A with respect to t can be written as dA over dt. To find dA over dt, we have to make the chain rule. To make the chain rule, we have to write the dA over dt separate like this. And as you can see in the blank section here, we can fill in the related variable. In this situation, we have to put dx. A negative rate of change is a decrease in the magnitude of the quantity involved as the time increases. For example, if the area decreases with respect to time at a rate of 10 meters squared per second, then it will be written as dA over dt is equal to negative 10 meters squared per second. There are many formulas that can associate with related rates problem, such as the solid geometry formulas, in finding the area and also the volume, such as the square base cuboid, the cube, the right circular cylinder, cone, sphere, and also hemisphere. So, in this formula, you have to know what is the total surface area and the volume for the solid geometry. Today, we are going to solve related problems, and it covers a lot of problems. But before we begin, let's talk about the derivative, and let's do some quick revision. Let's say, what is the derivative of x squared with respect to x? What will be the answer? The answer will be 2x. Next, what is the derivative of y to the power 4 with respect to x? By using power rule, will we get 4y cubed dy over dx. Likewise, the derivative of r to the power 5 with respect to t, what will we get? We will get 5r to the power of 4 multiplied by dr over dt. In solving related rates problem, we will always looking at the derivative with respect to time. For instance, let's say this equation, x squared plus y squared is equal to 1. What will happen if this equation, we derive it with respect to time for both sides? Now we have to differentiate with respect to time for each variable. The derivative of x squared with respect to time, we will get 2x multiplied by dx over dt. The derivative of positive y squared, we will get positive 2y multiplied by dy over dt. And the derivative of constant 1 with respect to time, we will get 0. And that's it. You are now ready to look at some of the application. Example 1. The radius of a metal discus is expanding at a rate of 0.02 cm per minute when heated. If at a certain instant the radius of the discus is 50 cm, the question asks how fast is the surface area changing. So now, let's pretend the metal discus is a perfect circle. So we essentially has a circle expanding at a constant rate. Now say we want to describe the rate at which the area of the metal discus is increasing, as well as the rate of radius of the circle is increasing. Both of these values are both increasing due to the expansion of the heated metal discus. Hence, the rates of increasing are both related. It is called as related rates. Let's say area is A and radius is R. The information given, which is dr over dt, or also known as the radius change over time, is given as 0.02 centimeter per minute. But what we want to know is that dA over dt, which is known as the change of area over time, at the moment of the radius is 50 centimeter. Our interest here is to find the dA over dt. So in order to find the dA over dt, we need to create the chain rule formula. So since that we know that there are two related variables, which is A and R, so we know that the chain rule will be dA over dt is equal to dA over dr multiplied by dr over dt. Then we have to find out what is the dA over dr and what is the dr over dt. In order to solve dA over dr, we need to relate what is the equation that can relate with A and R. And then we know that it is an area of a circle, which is A is equal to pi r square. And then we have to differentiate with A with respect to R, then we will get 2 pi r. And then substitute this back into the chain rule. So we get dA over dt is equal to 2 pi r, we substitute because at the moment of r is equal to 50, multiplied by 0.02. And then we'll get the answer is 2 pi centimeter square per minute. Actually, there is another way on how to solve this. It's by using implicit differentiation. So now back to the main formula, which is A equal to pi r square, the area of a circle. And from here, we start to do the differentiation of implicit differentiation. Now we need to differentiate it both sides with respect to time. From left side, it simply becomes dA over dt. But at the right hand side, the radius is the variable here. But the radius itself is a function of t. That is why we use the chain rule here. So we have to differentiate this expression with respect to r and multiply that with the dr over dt. So here we will get 2 pi r dr over dt. Then substitute all the available information given such that r, which is 50, and dr over dt, which is 0.02. We calculate dA over dt, then we will get the same answer, 2 pi centimeter square per minute. Example 2. Water is poured into a conical container at the rate of 10 centimeter cube per second. The cone points directly down and it has a height of 30 centimeter and a radius of 10 centimeter. How fast is the water level rising when the water is 4 centimeter deep? And now that we have identified the two related variables, which is height and volume, and we know that as the height is increasing, the volume also increasing. And these two variables is related. So based on this information, we already know that dV over dt is equal to 10. And now, our interest is to find dH over dt at the moment of the height is 4 centimeter. By looking at the figure, we can see that the water filled inside the container. And the water is now has similar shape as the container. And now, to find R and H, we can actually find it by using the ratio. And now, we put the ratio as R over H is equal to 10 as the radius and 30 as the height. Then we can actually get the radius is equal to 1 over 3 H. In order to solve this related rates problem, we must first know the volume of the conical container shape. According to the solid geometry formulas, the conical shape volume is given as V is equal to 1 over 3 pi r square H. And notice that in this formula, we get three different variables, which is V, R, and H. Since our interest is to find the rate of height, which is dH over dt, so we need to find the R value. to substitute back in the formula. Since that we already get the R value based on the ratio that we have been compute, which is R is equal to 1 over 3H, so we substitute back in the formula, we get 1 over 3 pi in bracket H over 3 square H. And we simplify it, we get 1 over 27 pi H cubed. From here, we need to do the implicit differentiation with respect to time. So we will get dv over dt is equal to 3. We bring in front, we get 3 over 27 pi h. 3 minus 1, you get 2. And don't forget to multiply dh over dt. And then we get dh over dt is equal to dv over dt in bracket 27 over 3 pi h square. After that, we substitute all the information values given and we get 45 over 8 pi centimeter per second. Now moving on to example 3. The diagram below shows a pendulum of constant length L centimeter makes an angle theta with its vertical position. Question A. Show that the height h as a function of theta is given by h is equal to L in bracket 1 minus cos theta. Now, to show the answer, we first need to cut out this right angled triangle that I red highlighted here. So as counted, we get the left side here as L minus H. In order to prove this answer, remember that we have learned about so ka tua, the trigonometric rule based on the right angled triangle. So in this case, we must choose ka instead of so and tua. Ka is actually cos theta is equal to adjacent over hypotenuse. Why we choose this is because we already have an adjacent and hypotenuse value, which is the adjacent is L minus H and the hypotenuse is L. So we get cos theta is equal to L minus H over L, as the left hand side is L minus H and the hypotenuse side is L. And then we multiply by L, we get L cos theta is equal to L minus H, and then we get H is equal to L minus L cos theta, and then factorize it will become H is equal to L in bracket 1 minus L cos theta. Now we have proved the answer. Question B. If length L is 50 cm and the rate of change of H is 18 cm per second, find the rate of change of the angle theta at the instant when H is 3 cm. We now know that the rate of theta is increasing as the rate of height also increasing. So these two variables is related. Now we collect all the information, which is dh over dt is given by 18, and we need to find d theta over dt. And note that L also given as 50 cm. And since that the hypotenuse side is equal to 50 cm, and L minus H at the adjacent side just now it become 12, and we can now find the opposite side now. So based on Pythagoras theorem, we get the opposite side as 9 cm. Okay, now to solve this related problem, just recall back the function that we have just proved now, which is h is equal to L minus L cos theta. Okay, from here, we need to make the chain rule first. As we are interested to find the d theta over dt, we need to make the chain rules like this, which is a d theta over dh multiplied by dh over dt. So back to the function. So from h is equal to L minus L cos theta, we can only find dh over d theta. But in the chain rule, you can see that it is a d theta over dh. But don't worry, it's just a reciprocal. Once you find the dh over theta, just reciprocal it, turn it upside down, and then fit it in the chain rule formulas. Okay, and then we find the dh over d theta first. The derivative of L with respect to theta is 0 because L is a constant. And then the derivative of negative L cos theta, we get a negative in bracket negative L sin theta. So the dh over d theta is equal to L sin theta. d theta over dh is equal to 1 over L sine theta as it is reciprocal. So d theta over dh is equal to 1 over 15 over, in bracket, 9 over 15 as we substitute all the formulas. Okay, now since that we get the d theta over dh and also the rate of height, so or dh over dt, now we substitute back into the chain rule, we will get the final answer as 2 radian per second. Now let's go for exercise 1. A 50-feet ladder is placed against a large building. The base of the ladder is resting on an oil spill and it slips at the rate of 3 feet per minute at horizontal length. Find the rate of change of the height of the top of the ladder above the ground at the instant when the base of the ladder is 30 feet from the base of the building. So, the variables that are related is x and y. X is the horizontal length and y is the height. As the ladder falling into the ground, we can see that the y is decreasing as x is increasing at a constant rate. Based on the information given, we know that dx over dt is equal to 3. And now we are trying to find what is the dy over dt at the moment of x is equal to 30. Now, by looking at the triangle and the information given, the ladder has a constant length of 50 feet and there is an unknown value of x and y. By Pythagoras theorem, we can create an equation which is the x squared plus y squared is equal to 50 squared. Now, at the moment of x is equal to 30, we now can substitute x is equal to 30 into the equation to get the value of y. So we get y here is 40. So from the Pythagoras theorem, we can actually do the implicit differentiation to solve the related rates. And then we differentiate it one by one. The derivative of x squared with respect to t, we get 2x dx over dt plus the derivative of y squared, we get 2y dy over dt, and the constant length we get 0. And then we simplify it by moving the negative 2x to the right, we get like this, and then we get dy over dt is equal to negative 2x over 2y dx over dt, and we cancel out negative 2, we get dy over dt is equal to negative x over y dx over dt, and substitute all the x and value, the x value and y value, negative 30 over 40, dx over dt already given, which is 3, so we get the final answer is negative 9 over 4 feet per minute. Exercise 2. A cylindrical can is filled with orange juice. The can has a 4 cm radius. How fast does the height of the juice in the can drop when the drink is being drained at 5 cm cubed per second? Now, there are two related variables here, which is the volume and the height. Based on the information given, we know that the rate of V is decreasing as the rate of height also decreasing. The dV over dt is equal to negative 5. It is negative because it's being drained out. So technically, the volume is decreasing. So now we are looking to find out dH over dt. And there is a constant value of radius, which is r is equal to 4. So in order to solve this, let's do two methods. First, by making the chain rule. So since our interest is to find the dH over dt, so the chain rule will be as dH over dV multiplied by dV over dt. First, we need to know the volume of the cylindrical shape. The volume of the cylindrical shape will be V is equal to pi r square h. And first, we need to differentiate V with respect to h. We will get pi r square. And then we should reciprocal it since the chain rule is dH over dV. So we will get dH over dV is equal to 1 over pi r square. Back to the chain rule, we now try to substitute all the available values now. So the dH over dV will become 1 over pi So the r will substitute, we get 4 square and then multiply by dv over dt, which is negative 5. And the answer will be negative 5 over 16 pi centimeter per second. Or the other way is by implicit differentiation. So the formula is v is equal to pi r square h. But because there are two variables there, we need to use the product rule. And then we make as pi r square as u, h as v. And then as the product rule formula given as u v prime plus v u prime, we will get dv over dt is equal to pi r square dh over dt plus 2 pi r dr over dt and h. And then substitute all the required values, and then we get negative 5 is equal to pi, the radius is equal 4 square dh over dt plus 2 pi, r is equal to 4, and then dr over dt, since that the r is constant, so if we derive it, it will become 0 and multiply by h. And simplify it, since we need to find dh over dt, so dh over dt is equal to negative 5 over 16 pi centimeter per second. Next is exercise 3. A spherical balloon is being inflated so that its diameter is increasing at a rate of 2 cm per minute. How fast is the volume of the balloon increasing when the diameter is 10 cm? Now we have two related variables here, which is v and d. The rate of volume is increasing as the rate of diameter is also increasing. So now we have dd over dt is equal to 2. And now we are looking to find dv over dt when the diameter is 10 centimeter. So we know that d is equal to 2r, which is a 2 times radius. So r is equal to d over 2. Based on this scenario, we need to find out what is the volume of a sphere. So the volume of the sphere, according to the solid geometry formulas, v is equal to 4 over 3 pi r cubed. So we notice that there is r, which is a d over 2. So we substitute that into the formula. We will get v is equal to 1 over 6 pi d cubed. So from here, we need to do implicit differentiation in order to get the related rates. So now we get dv over dt is equal to 3 over 6 pi d square dd over dt. From here now, we simplify, we will get 1 over 2 pi. We substitute the d formula, we get 10 square, and dd over dt, the value is 2. So we compute all the values, then we get 100 pi centimeter cube per minute. Before we end our lessons, so as a conclusion, there is 4 steps to solve related rates. First, you need to draw a picture of the physical situation in order to help you imagine on how to solve it. And then number 2, write an equation that relates the quantities of interest. Step number 3, take the derivative with respect to time of both sides of your equation. And also you must remember the chain rule. And last, you need to solve for the quantity that you are after. And that's it. We're now end of the lesson. So let's check your comprehension.